Managing the graphical interface by using CSS. This is the agenda. First off, we're looking at graphic effects, and then we'll be looking at 2D and 3D transformations. These new additions in CSS3 allow you to create a more engaging experience for users. 2D and 3D animations and transformations make moving from page to page more fun. Drop shadows and rounded corners make text and graphics more visually appealing. Creating rounded corners. In CSS3 you can now add rounded corners to layout elements including headers, footers, sidebars and images. You use the border radius property along with a length value such as pixels, ems or percentage. The higher the value, the more rounded a corner will be. Some browsers have problems rendering a percentage value, so for that reason it's better to use pixels or ems. You can round individual corners with the following properties: border top left radius, border top right radius, and border bottom right radius and border bottom left radius. Or you can just use a shorthand property, border radius, as in the example on the right hand side. Creating shadows in CSS3. Add drop shadows to elements using the box shadow property. A drop shadow is a visual effect that makes an object appear like it's floating above other objects on the document. There are 6 attributes that can be modified when using the box shadow property: H shadow, V shadow, blur, spread, color, and inset. The H shadow and V shadow attributes must be included, while the others are optional. These are the box shadow attributes. I'll let you pause the video and read through these attributes and their descriptions. Applying transparency in CSS3. You can apply the effect of transparency with the opacity property. Opacity determines how transparent an object appears. The value for the opacity object is a number between 0.0 and 1.0. 1.0 means that the object is entirely opaque, while 0.0 means that it is entirely transparent. The graphic on the right hand side helps to illustrate this. There's a rounded corners, shadows and transparency demo in the PDF document. Again, I would recommend looking at W3 Schools to have some more interactive examples of how these properties work. Background gradients. So a gradient is a smooth transition from one colour to another. In CSS3 you can apply gradients to a number of objects such as headers, footers, buttons and others. Gradients are applied through the background property, with one of the methods featured in the table to the right. So we've got linear gradient, which creates a gradient from top to bottom or vice versa, or from corner to corner. A radial gradient creates a gradient that radiates from the centre. A repeating linear gradient repeats a linear gradient, and a repeating radial gradient repeats a radial gradient with alternating bands of gradient colour. Linear gradients can be from top to bottom, bottom to top, or from corner to corner. The default gradient goes from top to bottom. You insert to top, to bottom, to right or to left as the first value with the linear gradient method to control the direction. Radial gradients start from the centre of an object and radiate outwards. The first values used with the radial gradient method determine the horizontal and vertical centre values. For a gradient demo, you can look in the PDF, but I also recommend looking at the CSS3 gradients information on W3 Schools. Next up, we're looking at 2D and 3D transformations. Transformations. In HTML and CSS3, you can now transform 2D and 3D objects. A transform is an effect that lets you change the size, shape and position of the element. This includes rotating, scaling, stretching, spinning and moving elements. To add transformations, you use the transform property with one of its methods. These are the methods for the transform property. We have matrix, which specifies a 2D transformation using a 6-value matrix. There's matrix 3D, which specifies a 3D transformation using a 16-value matrix. Perspective specifies a perspective view for a 3D element that's been transformed. Rotate rotates an element in 2D. Rotate 3D rotates an element in 3D. Rotate X rotates an element in 3D along the axis. And rotate Y rotates an element in 3D along the Y axis. Rotate Z rotates an element in 3D across the Z axis. Scale XY scales an element in 2D. Scale 3D scales an element in 3D with the width, height and an arbitrary vector in 3D space. Scale X scales an element in 3D along the x-axis, and scale Y scales an element in 3D along the y-axis. Scale Z scales an element in 3D along the z-axis. Skew skews an element in 2D along the x-axis and the y-axis. Skew X skews an element in 3D along the x-axis. Skew Y skews an element in 3D along the y-axis. Translate translates or moves an object in 2D. Translate 3D translates or moves an element in 3D. And then translate X translates an element in 3D using the x-axis, and translate Y does it on the y-axis. Translate Z does it along the z-axis. You can look at all these on W3 Schools and then have a play with the different examples that are provided there. That's really the best way to gain an understanding of how these are actually implemented and how they operate. Let's look at 2D translations. A translation simply moves an element without rotating, skewing or turning the image. To translate an object, you use the transform property in combination with the translate method. The translate method accepts two values, one to adjust its position on the x-axis and another on the y-axis, as you can see in this example underneath, where it's been translated 200 pixels to the right and 0 pixels along the y-axis. 2D scaling. Scaling an element will increase or decrease its size. To scale an object, use the transform property in combination with the scale method. The scale method accepts two values, a factor to adjust its width and another to adjust its height, as you can see in the example below. Again, I direct you towards W3 Schools to look at this in more detail. (2D) rotation. Rotating an element will turn it clockwise or counterclockwise. To rotate an object, use the transform property in combination with the rotate method. The rotate method accepts one value, the number of degrees to rotate the object. You can see this in the example on the right hand side. 3D rotation. 3D rotation will rotate an element around its x-axis or y-axis. To 3D rotate an object, use the transform property in combination with the rotate X or rotate Y methods. The rotate X and rotate Y methods accept one value, the number of degrees to rotate the object around an x-axis. You can see the visual result of these rotations on the right hand side of the page. 2D skewing. Skewing an element will stretch it in one or more directions. To skew an object, use the transform property in combination with the skew method. The skew method accepts two values, the number of degrees to turn the object around the x-axis and another for the y-axis. You can see the example on the right hand side of the screen. Transitions. A transition is a visible movement from one state to another on screen. To create a transition, use the transition property. Set the value as the property that you would like to change. You must also set the duration, the delay, and the timing of the function. This can be done with the transition property or by using specific properties for each. The following are the CSS3 transition properties. I'll let you read through this slide. You can pause the video here. Animations. Animations move static images in a way that makes them appear as though they're moving. Unlike transitions, animations use the keyframes rule, which allows you to adjust the timings of an animation. You can dictate when an action occurs by using a percent, i.e. 50% of the way through this animation the element should be yellow. Okay, so it's worth having a look at the keyframes example on the right hand side. And again, you can find examples using keyframes on W3 Schools. These are the CSS3 animation properties. Again, I'll let you pause the video to sort of read through these yourself. And again, you can see them on W3 Schools. So, to summarise, we've looked at graphic effects and 2D and 3D transformations.